So,
Nice.
thanks for joining.
Yeah, we can get started.
Yeah, let's get started.
Great.
We'll introduce ourselves in a minute, but the goal of this session is to have a discussion about the new role of a data engineer in the AI era. So we'll speak a little bit about like concepts and what has changed in the environment, and we'll also dive into like practical tips and more down-to-earth stuff that have changed in the data engineer role. So my name is Lee. I was leading the Gen AI at Lemonade Insurance for the past 2 years, where we've been building different types of agents for customer support and for text-to-SQL agents and stuff like that. And also I'm leading together with Gal LangTalks, which is the largest AI engineering community in Israel. We have a podcast. It's in Hebrew, so I guess most of you won't understand. But we also have we're also doing like events and stuff for the Israeli AI engineering community.
Hello, I'm Gal. So I come from a background of software engineering. Then did my transition, did my master in NLP back then in 2018. And then so I went to all this transition between like transformer, like low-level NLP and data science model to this like era of LLMs. Built all sort of agents. Currently I serve as head of AI at Carbine, and I served as head of AI in several startups. So I was witnessed all this like transition from NLP models, which was fine-tuned to a specific task, to this like era of LLM everywhere in your product. And today we are using them when we write code, when we analyze data everywhere. So yeah.
Great. And hello, everyone. My name is Guy Fiegel. I'm a practitioner. I used to run data infrastructure, data engineering, and AI for multiple companies. Started in the cyberspace, moved into distributed cloud space, and then started a few startups. One which was acquired by New Relic, the cloud company. At New Relic, I used to run all data analytics, data engineering, and the AI platform for the company. So I've seen the transition from classifiers all the way to agentic, the agentic move in a very, very large scale. And nowadays I've actually crossed the chasm and started to basically invest in companies and startups. So I'm a partner at Hetz Ventures, which is one of the leading venture firms that is investing specifically in data, AI, and infrastructure. And as part of that, I'm seeing and meeting lots of different founders, different startups that are in the cutting edge of technologies, and some of the things and topics that we're going to talk about today. So part of me is still a practitioner, the other part is just an investor and kind of a mixture in between. And I've been collaborating with those two guys for a few years now. So happy to be here.
Cool. So let's dive into it. Let's start with speaking about how data usage has transformed in the past couple of years with AI. So if until now we had analysts as the main users for our data, now we have agents and we have AI engineers. So Gal, what has actually like transformed in the way the new users are consuming the data?
I think like we should look on the new consumer, right? Right now we have agent. How many of you heard about the word MCP? Raise of hand. Right. So yeah, we know right now that we have this new interface. New users, agents consume as our data as like another entity in the organization. So the question is maybe what we need to do differently, right? What we need, how we can ingest the data. Why won't us just hook up this new MCP into the data, give it direct access to the agent, and it just works, right? The problem is that when we, as human, do this kind of analytics and query, we already have like the knowledge about the data and how it models and everything. Agent doesn't. So what we need to do is basically we need to bridge this gap, the semantic gap, the meaning of what kind of data do we have, what does it mean if this table exists, what does it mean, what kind of relation it adds to other tables in the data set. So we need to bridge this gap, and I think this is the main thing that the new data engineer job to be done need to concern about.
And maybe I would add to that is think about the personas. In the past, we had a person, we had a human being actually driving SQL query. When you are driving an SQL query, the definition of the data model itself is inherent inside your query, whether the query works or not. If it doesn't work, then there's a problem in the semantic. If it works, then you're getting basically what you were trying to receive. It's all very structured when you think about it. In an agentic world, everything is probabilistic. It's all based on the LLM model and then what type of information you're feeding into the model. So if you don't have and if you haven't organized your data with semantic meaning and with context, which we're going to talk about, then your agent is going to be a little bit kind of paralyzed when it comes to complex situations. If it's going to be a super easy question then or a task, then the agent will be able to perform that. If you really want to achieve a dynamic agentic flow, multiple workflows, multiple agents, swarm of agents communicating between themselves, those are no longer human beings. Those are basically pieces of code that are running constantly, and you need to provide helpers into that piece of software so it will actually perform the job. And that requires a whole different set of thinking. As data engineers, we need to start thinking about how do we build scalable system that will allow other programs and other automated solutions to be able to achieve high level of intelligence out of the data. And that's a completely different way of architecting our data sets, our pipelines, everything that we are thinking about.
And until 2 years ago, we had as data engineers to prepare the data for analysts to query it, and now we need to also think of how agents going to query it, and for that we need to create this layer of discoverability. So documenting metadata and documenting explanations about tables and about columns and about connections between tables and all these kind of things are types of semantic representation of our data warehouse that enables discoverability of the data by the agent. And up until 2 years ago, we didn't have to do that, and it's a new skill that data engineers now need to acquire, like how agents discover data, like what's their process, like what kind of tools are useful for this discoverability. And let's take an example of like an MCP of a different, of an external product. So MCP, just to align everyone, a model context protocol, it's the like bunch of tools that are accessible for any LLM or any agent to use. And for example, there is like a Figma MCP and Slack MCP and Jira MCP, and in each of those MCPs, the company that built it has engineered a few tools that help to discover the data inside the resource. So like in Jira, it would be like get tickets and maybe get epic details and stuff like that. So when you think about internal data, we need to configure tools to let the agent discover what's inside the database. So as data engineers, we have a new role and a new goal to make the data accessible through MCP and to design it. So maybe let's talk a little bit about design partners of MCP.
Yeah, I think like it's more like use case oriented, right? It's not like just for analytics. You're not going to ingest the data just for fun, right? You have this use case, for example, coding, dev agents, and you ingest, for example, the code, the GitHub code or whatever, with this like use case in mind. And right now, it's not only offline indexing, right? The traditional data pipeline, where mostly offline, when you model the data in advance, you understand what kind of index you want to put there. So right now, because you have this semantic layer, right? So you have also online phase, right? You can also do the last mile of analytics with your kind of agents, right? So you have this offline phase, you index what you can, you model what you can, and now you have your data with your semantic layer, and maybe you can provide to your user an agent that can get a task for, let's research something, and it can utilize this offline phase, this indexing, but then also can get the last mile, give you the, let's say, load this like data into the data frame and do something with pandas, for example, to do this like last mile aggregation or summarization and give a better response, right? So it's not only offline. You can also give your prospect, your users, also this like new kind of application or interface that it can communicate with.
I think maybe to summarize kind of in a very easy way, as data engineers, what changes, right? So in the past, data engineers, in my mind, we are plumbers, right? We have pipes. We're dealing with pipes. We're connecting things, connecting systems. When it comes to the new era of AI and agents, we are now basically becoming curators. Think about, like, we need to start thinking about what types of data, real-time, offline, where the data is, and curate a set of different types of data and give it accessibility that will enable in an easier way the agents to start receiving that information wherever they are, whether it's an offline, whether it's a batch processing, whether it's an online, whether it's real time, doesn't really matter. So our focus now is shifting. We need to understand how models are working, how data is getting accessed, what is the required kind of data types, whether those are embeddings and vectors or whether those are in tables. So we are becoming curators of data for AI. It's no longer like data plumbers for pipelines.
Cool. Let's maybe talk a little bit about new skills that data engineers need to acquire. So let's just speak about an example. There is a team of AI engineers in the organization that are building, let's take an easy example, text to SQL agent. And these guys now, they have access to the data warehouse, and they're trying to build the agent so that it can answer questions over the database. Now, these guys, the AI engineers, let's assume they don't have the support from the data engineering team. They have to understand how, like, the data model, and they will come to consult, and they will basically build a semantic layer for themselves, just for the specific things they need for their use case, and it will remain on their solution. And with data engineers that better understand how AI engineering works and can communicate more smoothly with the AI engineers and take responsibility from the AI engineering teams and build the semantic layer for them, for their specific use case, it enables the creation of a platform of the semantic layer for further use cases. So I think one of the skills is understanding how the agent is collaborating with a team that is building the agent, so you can get the semantic layer to actually work with them. For that, for example, you'd need to understand how evaluation works. So evaluation is a mechanism of testing in a statistical manner how well your agent performs. And in the context of semantic layer and agentic search, you'd want to check how well the agent can get to the actual useful data that it needs. So, for example, if we build a text to SQL and the query that the agent is now trying to solve needs 3 specific tables, it needs to use only these 3 tables. If it actually after the agentic search, it gets to 3 other tables or 5 other tables, it did a really bad job. So we'd get like score 0 on the retrieval part. And by getting this feedback that it failed on a certain query, we can look at how it behaved and what was the process of the agentic search and what were the steps that didn't work well and improve the semantic layer there and see the improvement gradually so that the evaluation metric would improve.
So you
yeah,
mentioned
go ahead.
like semantic layer a lot, right? So maybe let's give one example. What does it mean? So let's say that we have this like data warehouse or SQL database, and we want to extract metadata. So metadata is also a keyword, a buzzword that we use a lot. But what does it mean when we build, for example, this text to SQL solution? So what we need to do is basically to bridge the gap, the semantic gap, or the meaning between this like structured data and the understanding that we have why we created this structured data to begin with, and to bridge it to the LLM as a semantic layer or a description. So maybe what you can do is basically take the table and extract description. Why do we have this table? And maybe we have foreign keys and we can use it and enrich it with LLM. So this table connects to this table, so the location field here have a context. This location is basically, let's say, tied to a specific table, so we can give a description on the condition that this is the location of a specific entity in the table, in the SQL. And then when we have this enrichment, right? So we have other challenges. What does it mean to use LLM on scale, right? We have big data. What does it mean to enrich the tables, the relationship, the field with LLM, right? We have this batch processing and other things that we need to take care of. But these kind of things really bridge the gap to those kind of agents, and this is what does it mean really semantic layer.
I think just to answer again from a very kind of broader perspective, what do we need as the data engineers to learn to be able to be and keep relevancy in the new world? First, you have to understand vectors and embeddings, something that until now, as data engineers, we didn't need to even learn or know. You really have to understand real-time streaming data pipelines, because most of the enrichments will happen there. No longer static enrichments where you actually pipe a source to a destination. You have a table, and then you have another table that enriches the table, and then a SQL will actually query it, and you can basically join between the tables. That type of architecture is pretty much gone. It's mostly around real-time enrichment as part of streaming data pipelines. So learn that. The third is the models themselves. How do you choose, for example, GPT 3.5 versus 5? 5 is better than 3.5? Well, not really. Depends on what you need to do with it. Do you need Claude or do you need Gemini? Do you need your own SLM, like small language model, or do you need to go outside, right? Like understand how large language models works, and you don't have to really understand how to create one, but you have to understand how to operate one. Prompt engineering, super useful, and then how do you evaluate? So evaluation tools, all the way to context. What does it mean, context? How do you provide access and reasoning to external tools via MCP, via A2A, via other protocols that are out there today? All of that is tying up together into the new skill sets of data and AI engineers, because without that, we're no longer relevant, right? Like in this new world. Why is that? Because the basics things to query with static SQL, the models themselves are pretty good at that. So we're no longer needed for that. But it is crucial to actually learn all the different systems and how these different tools are connected. And that's where we can really bring value and reduce the number of people and reduce the time to get into value into our businesses.
Cool. We really want to keep this session practical, so I try to give we'll try to give a couple of examples of the actual skills of what you need to understand. So I'll give you the perspective of an AI engineer building text to SQL agent, how the agent actually works. Like, what are the tools that I want it to have in order to do the context engineering in a good way. So let's assume we have hundreds of tables in our data warehouse. If we'll have this amazing semantic layer of descriptions and sample data and description of the connection between tables, we'll have huge amount of documentation, which is really nice, but it won't fit into our agent context window. So as an AI engineer, I'd want to have this agentic search in a gradual manner. It means that first tool I'd expect to have is get list of all tables. Then I'll have a list with a very brief description of each one of it. And then I expect the agent, like my agent, to be able to pick a short list out of these tables. So from hundreds of tables, I narrowed down to maybe tens of tables. And then the second tool will be get detailed description for tables. And then I will give it a list of tables and get detailed explanation about them. So I can narrow even more the relevant tables. And then the third tool might be get detailed information about a certain table. For that tool, I would get not only the description, but also the schema, maybe even sample data from the table, and then we can speak about what useful sample data can we give to the agent. Is it just first 5 lines in the table? Probably not. We want diversity. We want big variance of the data. Maybe my agent, like text-to-SQL agent, can provide some context of what it looks for, so this sampling of the rows from this specific table would be smart by a semantic search of the specific values in the table, and so on. So gave you like 3 examples of tools that I expect my text-to-SQL agent to have.
So how many of you are familiar with embedding? Yeah, less than MCP. So embedding is basically the new way of indexing unstructured data, right? So we, as a data engineer, need to be familiar with these kind of tools. We need to understand how we can really index in this semantic layer, right? Because creating those description is not enough. You need to index that and provide agent a better way. Basically, embedding is a presentation for those agents that they can narrow down, do a retrieval, understand what does it mean to be similar to the query, right? So we need to understand those kind of new breed of indexing when we talk about unstructured data. And then we need to be creative when we create them. So for example, let's say that we want to teach the agent to understand what kind of value you need to pick in order to filter a specific location. So we have this field location with a type string. This is not enough because location can be an acronym of the location, right? So maybe the first 2 letters of the location, and maybe it can be the full name of the location. So if agent just guess the right value, it's going to fail, right? So maybe what we can do is pick the logs of the SQL to understand what kind of query people do, what kind of value they put there, right? And then create these few-shot examples. How many of you know what is few-shot examples? So those kind of examples, that how to use the data, right? We can provide those agents, those few-shot examples, and they get astronomically better when they are trying to do the action themselves. So we can learn from human, from the real query, like utilizing the metadata or the logs of the SQL query server, extract embedding from it, understand what is the intent of the user, what is the current intent, get those few-shot examples, for example, and then provide the agent in real time, on the fly, example how to do a specific action. So this kind of things, this is what I would expect if I will build as an AI engineer. This is what I would expect from my data engineer as an infrastructure.
Yeah, and maybe I think to try and wrap up, I think we are almost at time, kind of like talk about who are the new data consumers in the organization. And up until now, if you think about it, mostly the classic consumers for data engineers were kind of what we call the business users. Usually analytics, user analytics, people that wanted different dashboards, and they were our consumers. With the shift into the agentic movement and the new technology, we now need to serve three types of users. The first, classic business users. People that actually don't understand what agents are. They just hear about the buzz in the media, and now they want to basically have like a natural language query. That's one persona that we have to serve. The second, the LLM agents. As we talked about in this conversation, we use most of our times to kind of discuss the LLM agents themselves, the technology, what they need, what do we need to provide to them to be able to do their job, to perform. And then the third, which is kind of a new persona for the data engineers, actually developers and engineers. So engineers that are using now code assistance and other AI capabilities becoming data engineers customers. Why is that? Because when you're thinking about code assistance and any AI augmented solutions for the developers or the engineers, which are not data engineers, they will often come and require for specific context regarding their enterprise or their company that they're working, right? So it's no longer relevant anymore to say, okay, I'm just going to use code assistant without any context to how my linters are working, what are my Jira specific requirement, what type of open source libraries I'm not allowed to use, okay, or what are my guardrails. So data engineers are crucial to, and becoming crucial also to guide the developers and provide them with some internal tools and capabilities so they can plug into other tools to do their job much better. So three new personas.
Cool.
Thank you very much.
Thank you, everyone.
All right. Thank you.